Here we have two kinds of graphs. One is displacement time graph, known as xt graph, velocity time graph. Vt graph. In this video, we are going to discuss about displacement time graph only. Velocity time graph will be discussed in the next video. Displacement time graph is of two kinds. One is displacement time graph for velocity and displacement time graph for acceleration. Let's start with displacement time graph for velocity. For velocity. Velocity can be defined as v equals to dx by dt, or the slope of xt graph. Velocity is the slope of xt graph. First kind of graph. If the graph is a horizontal line or a sleeping line, as time increases, the position is not changing. At 2 seconds, the position is 20 meters. At 4 seconds, also 20, 6 also 20, 8 also 20. That means the person is not moving. He is just standing at that position. Okay. So velocity can be defined as change in displacement by change in time. But displacement is not changing. Then the change in displacement is 0. Then the whole velocity is 0. What does it mean? The person is not moving. He is at rest. Okay. Look at these two graphs. These two are straight lines. One is an increasing straight line, another one is a decreasing straight line. So now find velocity for this. Velocity is the slope, right? That is dx by dt. Find slope at any point. For suppose I am taking this point as center. Draw a triangle like this. This side of the triangle represents change in x. This side of the triangle represents change in time. Change in x is dx is 10. Change in time dt is 2. 10 by 2 is 5 meter per second. So the slope or the velocity is 5 meter per second. Because it's a straight line, wherever you find the slope will be same throughout the straight line because it's not a curved line. So the slope is constant everywhere. Slope means velocity. Velocity is constant everywhere. If velocity is constant, we call this motion as uniform motion. Uniform motion. This is also a straight line. Then the velocity here also constant. Then this motion is also a straight line or uniform motion. Remember, if the xt graph is a straight line, then the velocity is uniform, constant. Okay, this is an increasing graph, so the velocity is positive. This is a decreasing graph, velocity is negative. What's the practical difference between these two? Suppose a person is there, he started his journey from his home. He moving away from the home. As time increases, the distance increases. 10 meters, 20 meters, 30 meters, 40 meters away in this direction. This graph represents the person is approaching home. He is moving towards the home. As time increases, distance decreases. Distance decreases. That means he is approaching home. This direction we are taking as positive. This direction we are taking as negative. That's why this velocity is positive. This velocity is negative. Okay. Remember one point. If the graph is a straight line, then the velocity is uniform. For these two, velocity is uniform. What if it is not a straight line? If it's a curved line? What if it's a curved line? For a curved line, the slope at different points is different. Slope here is different, here is different. So the slope is different at different points. Slope means velocity. Velocity is different at different points. That means this velocity is not constant. That means it's not same everywhere. It is a non-uniform velocity. If the graph is a straight line, that's a uniform velocity. If it's a curved line, it's a non-uniform velocity. And the distance is increasing with time, then the velocity is positive velocity. If it's decreasing with time, then it is a negative velocity. I hope you understand this. Next, let's start displacement time graph for acceleration. Acceleration. A is defined as double derivative of x with respect to time, or you can write it as dv by dt. Okay. That means we are including displacement time graph with acceleration. If displacement time graph is a straight line, as we discussed earlier, if it's a straight line, then velocity is constant, that we know. Velocity is constant in both the conditions. When the velocity is constant, acceleration is derivative of velocity. If you differentiate this constant, it becomes 0. A is 0. So, if xt graph is a straight line, either increasing or decreasing line, if it's a straight line, then acceleration is 0 because velocity is not changing. If xt graph is a curved line, then velocity is not constant, then we have acceleration. If it curved upwards, this is curved upwards, right? The graph is curved upwards, then acceleration is positive. Remember this. If the graph is curved downwards, like this, if it's curved downwards, acceleration is negative. Okay. Remember these 2 points. If it's a curved upwards curve, then the acceleration is positive. Downwards curve, acceleration is negative. If it is a straight line, then the acceleration is 0.